Thursday.
Hexadecimals, handy stuff. We don't really need hexadecimal. But when you start seeing binary numbers, up to a point your eyes start to hurt. So here we've got numbers of this value. The number 255 would be, that's one hoot, a lot of ones basically. And shall we say 251 would be that. And after a while you look at this and your eyes start to blur. You can't work out where the ones and the zeros are. It's like those really inflated foreign monies where there's so many zeros in the banknotes you can't work out if there's a million note or a 10 million or a 100,000 note. We can help by writing them in sets of 4. That's the same number. Put a tiny gap over there, but you just see what's going on. But even that, as the numbers get big, does start to get a bit of a nightmare. Hexadecimals are power. Hexadecimal to the rescue. When we are denary decimal base 10, we assume we've got 10 fingers. Now, hexadecimal is some strange alien being who's got 16 fingers. Which might seem after a point to be a bit annoying, but it's right useful. They can count up to 16 without starting again. They can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Nothing wrong up there. We've got 0, 2, as you do. We need to invent names. Imagine, for example, rather than me having 10 pinkies, I've got 16 pinkies. And I need to invent numbers or names for the following extra ones. So I'll call them A, B, C, D, E, and F. And when I'm counting my children to school in hexadecimal, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And the 15th kiddie is number F. The 16th kiddie would be number 10. As in 1/16 and no units. The 17th one would be number 11. And if we think of that, we pretended that was 10, 11, 12, 13, 14, 15. Then we'd know that the 1/8 one would be 16 plus 10, that's the 26th one. That's the way the hexadecimal works. Where it's most commonly seen in web page colours. So you'd have something, for example, like double F, double F, double F, double F, and that's, see it that way. As in, I'm dreaming with double F, double F, double F, Christmas. That's white. And in fact, we've got a red, green, blue, so we could have Rudolph, the double F, double O, nosed reindeer, and so forth like this. That's the way they work. Now, this is what you most often come across in usual life, the hexadecimal. If you're playing around with your machine and setting network settings, the settings, things such as your media access card, perhaps your network card or your Wi-Fi card, will be hexadecimal as well, to make more sense out of it. On this particular bit, in effect, that's 255. That's 0, that's 0. Not much worry there. The 255, for example, so that's F and F. So we've got F16s and F units. So F is 15, 15 times 16, 160 plus 38 would be 240, and F units would be 255. That's my F comes from. And oddly, 255, if we roll back a bit, is that. So instead of having to write 1111, 1111, 4 bits of 1, I can write double F. So hex is my shorthand for binary. Rather than writing all of this, I could write that. That'd be 8 ones, 8 more ones, and 8 more ones. 8, 16, 24, that's an awful lot of ones. I can write instead 6 Fs. That's my hexadecimal comes in. To convert things, use their fairly small numbers, so that if I had my 16 times table, I would have, for example, 16 and 255. 255, I think, and units. If, for example, I had number 36, then 2 16s go into that. I've got 32 gone, 4 left over. That's the number 24. If I had number, say, example of 92, well, 5 16s are 80, so I've got a 5. 80 used, 12. Now 12 left over, using my handy cribber, 5C is the same as 92.